This is a members only video. What I've done is gone back and looked at years and years of IB multiple choice questions on kinematics. Looked for those concepts that get asked repeatedly. And then what I did was I made up my own questions. So they're IB style questions, 25 of them that I'd consider to be great IB multiple choice questions on kinematics. The first few questions are going to be about average and instantaneous speed. Here's the first question. Pause the video, read the question over, come back for the answer. So I guess the warning here is don't take the average as just the average between the two speeds. Don't just add 6 plus 1, that makes 7, divide by 2 to make 3.5. That would not give the correct answer. The average speed, by definition, is going to be the total distance divided by the total time. And the total time is going to be 15 seconds plus another 10 seconds. So this was moving for a total of 25 seconds. And then the total distance, well, if you move at 1 meter per second for 10 seconds, you're going to move 10 meters. And if you move at 6 meters per second for 15 seconds, you're going to move 6 times 15 or 90 meters. So we get 100 divided by 25, which is 4 meters per second. Correct answer was C. Okay, question 2. So we've got a person that moves along this path here from M to N, and they do so in a time of 60 seconds. We want to find out the average speed and the average velocity. Pause the video, try the question, come back for the answer. Let's get the average velocity first. So the average velocity, by definition, is going to be the displacement over time. And the displacement has nothing to do with how far we travel. All it depends on is the first point and the last point. It's just a vector from that first point to that last point. So this vector is 10 meters plus another diameter here, another 10 meters plus another 10 meters here. So it's displaced by 30 meters. If we wanted to put in a direction, we could say to the right, and it does that in 60 seconds. And so the velocity there would be 0.5 meters per second, and that's to the right. So our answer has to be either this one or this one, B or D. Let's look for the average speed now. For the speed, it's a distance over time. So this time you have to look at the path. And the path here, well, 10 meters to get to this point. And then really he's going around a complete circle here. So that would be 10 meters plus 2 pi. The circumference of a circle is 2 pi r. And r was 5. And once again, that's done in 60 seconds. So we end up here on the top with 10 plus 10 pi divided by 60. And then I can divide top and bottom by 10. So I'll get 1 plus pi over 6. So the correct answer is going to be D here. Question 3 involves instantaneous and average speed. Pause the video, try the question, come back for the answer. So let's do the instantaneous speed first. So we're talking about what is the speed at 15 seconds. And you can see it's actually a constant speed. It's moving at 8 meters per second. The answer's got to be either B or D. Now, for the average speed, of course, once again, that's just distance over time. Time's easy. We're talking about an object that moved for 15 seconds. The distance, well, we figure out how far did it move when it was moving at 8 meters per second. It moved at 8 meters per second for 5 seconds here. 5 times 8 would be 40 meters. If you move at 8 meters per second for 5 seconds, you'll move 40 meters. And that's just equal to the area under the curve here. Now, in this region here, the average speed would be halfway between 0 and 8. The average speed would be 4 here. And if you move at 4 meters per second for 10 seconds, you're going to move another 40 meters. So we can either kind of use the average speed, and that would be this area, or you can look at the area under the curve. Those two will be exactly the same. The area under the curve will equal 40, and if we go at an average speed of 4 meters per second for 10 seconds, we'll go 40 meters. So we end up with 80 divided by 15. 80 divided by 15 is approximately 5.3. So our correct answer is B. Question 4 involves the relationship between a maximum speed and an average speed. Pause the video, try the question, come back for the answer. So what we need to realize here is that we know the total distance traveled, it's 120 meters. And we also know the time it took to travel 120 meters. That would be 10 seconds, which means that the average speed, which is just that total distance over time, is going to be 120 divided by 10, or 12 meters per second. So if we go at an average speed of 12 meters per second for 10 seconds, we're going to go 120 meters. Now, this V average has to equal V max divided by 2. As long as we have uniform acceleration, and that just means a straight diagonal line here and here, as long as those are straight lines, the average speed will just be half the maximum speed. And you can kind of see here that this area in blue is the same as the area under the curve. In other words, both of those motions would give the same distance in 10 seconds. So that V max is just going to be equal to V average times 2. So 2 times 12 would give 24 meters per second. And so the correct answer here would be C. Question 5. Pause the video, read this question particularly carefully, try the question, come back for the answer. So let's imagine, here's our circular track, and the person's running around the track. The displacement vectors would look something like that. And you notice how quickly the length, the magnitude of these displacement vectors is growing. But when we get up near the top here, halfway around the track, it's a slow growth towards that maximum length displacement. And then all through this section here, the displacement is pretty much constant, and then it begins to decrease again. So what we want is a displacement that starts out, well, at 0. It needs then to increase rapidly, and then it needs to increase slowly. So here you can see that these are increasing quite rapidly here, but in the middle they're increasing slowly. So this here, answer A, is correct. So make sure that you notice that word magnitude in there. It just means the length of the displacement vector. What's happening to it? Let's look at some problems involving areas and slopes of motion graphs. So here's question 6. Pause the video, try the question, come back for the answer. So what's important to keep in mind here is that here's a position time graph. The rate of change of position is what we call velocity. So we can use the slope of the xt graph to get the values of the vt graph. And we can repeat that process again if we come down another level, because the rate of change of velocity is the acceleration. So once again, we can use this idea that the slope is equal to the value. Now we can also work in the opposite direction. If I work upwards, the area, in this case the area under an AT graph, would be equal to the change in the graph above it, the change in velocity. And similarly, we can go up here. The area under the VT would be equal to the change in position, which is what we call the displacement. So we can take the area of a VT graph to get the displacement, and we can use the slope of a VT graph to get acceleration. So it's these two quantities that we could get from the slope and area of a VT graph. Now, of course, we could get the change in velocity from a VT graph, but that's not from the slope or area. It's just from the values on the graph. So the correct answer here is B. Question 7. Pause the video, try the question, come back for the answer. Answer A, the objects arrive at the same position. Well, actually, from a VT graph, we have no idea what the position is, so that can't be said at all. Answer B, the objects have the same magnitude of acceleration. Well, acceleration is the slope of the VT graph, and the magnitude of these two slopes is the same. One's a positive slope, one's a negative slope, but their magnitudes are the same. So B is going to be the correct answer. Just for completion, let's take a look at C and D. Both objects start from rest. No, this object B here starts with considerable speed. And the two objects are traveling in opposite directions. No, they both have positive velocities. A negative velocity would be down below the axis. Question 8. Pause the video, try the question, come back for the answer. So what's important to realize here is that these are all magnitude graphs. There's no negatives. So direction really becomes irrelevant here because any directions that we take as negative would show up as a positive graph anyways. So what we kind of want to notice here, on the first graph, the speed would represent the slope of the dt graph. So what you want to notice here is that we're going from a high speed to a low speed. And the second graph as well. It's very steep here. And then it gets flat. So it's going from fast to slow. This one here, it starts out with 0 speed and ends up with a high speed. So this one cannot represent the first two. This one, though, it starts out with a high speed and ends up with a low speed. So that one's consistent. And this final one here, it just says that the acceleration's constant. So on a VT graph, that would show up as a straight line. So that's consistent here. And on a DT graph, on a position time graph, it should show up as something that looks like a parabola. And these are potentially parabolas. So this one, this one, this one, and this one are consistent. The only one that's not consistent is number 3. So the correct answer here would be B. Question 9. Pause the video, try the question, come back for the answer. So when we've got an AT graph, the area under an AT is going to be the change in the quantity above it, the change in velocity. So the area under the AT graph would be this here. You notice it is a positive area. It's above the time axis. And the area would be what, half base times height, or 1/2 4 times 8, which is 16. So it's a positive 16 because it's a positive area, and that's equal to the change in velocity. So the answer here is D. Also note here that initially the object's gaining speed. And later on, it's still gaining speed. It's not gaining speed as quickly, but it keeps gaining speed. So all the time, it keeps gaining speed all the way until at 4 seconds, it stops gaining speed. And that's what we mean by this positive change in velocity. Question 11, pause the video, try the question, come back for the answer. So we're looking for the true statement, only one runner began at the sound of the starter's pistol. Well, both of these guys started at time 0. So they both started at the sound of the starter's pistol. That's not true. The slowest runner won the race. So we'd be looking for the flattest line, the line with the lowest slope. This is the flattest line. This is the slowest guy. But you'll notice that M finishes last in time, the longest amount of time. So that's not true. The runner who started last finished first. Okay, these two started at the same time, but there was a time delay before O started. And he ends up with the lowest time. So that's the correct answer. Last answer, the runner with the head start won the race. It was this guy who had a head start. right? And he finished last. He was a very slow runner. So correct answer is C. Question 11, pause the video, try the question, come back for the answer. So velocity here is the slope on a position time graph, and we've generally got a positive slope throughout this curve. It's always heading upwards, so the velocity is positive. For the acceleration, this part of the curve is concave up, but this part of the curve is concave down, and concave down implies a negative acceleration. So the correct answer is A. Question 12, pause the video, try the question, come back for the answer. So what we need to do here to find out the acceleration at 3 seconds is to draw a tangent line right at 3 seconds here. Here's the 3-second point. So we need a tangent line there, and then we need to figure out the slope of that tangent line. So here is a pretty good tangent line at that point. The acceleration is going to equal the change in velocity over the time interval. So it increased its velocity from 8 to 14. So 14 minus 8. In a time from 0 to right about here. This is going to be 7. So maybe 6.4 seconds. This is about 6.4 seconds across here. And our rise here was 14 minus 8, or about 6. So we get an answer there of approximately 1, 6 over 6.4. And so our best answer is B, 1 meter per second squared. Let's look at some questions involving the motion equations. Pause the video, try the question, come back for the answer. So two things that we can figure out really quickly here. One would be the average speed. We know that it starts at a speed of 10 meters per second, and then it comes to a stop. So its final speed would be 0. So its average speed has to be halfway in between 10 and 0. So the average speed, well, 10 plus 0 divided by 2 is 5 meters per second. The other thing we can find out really, really quickly is the amount of time it takes to come to a stop. Because we know it started at 10 meters per second, and then it loses 2 meters per second of speed every second. So after 1 second it'll be going 8, 2 seconds it's going 6, 3 seconds it's going 4, 4 seconds it's going 2, and 5 seconds it's going 0. It's come to a stop. So the time has to be equal to 5 seconds. And the total distance will have to equal that average speed times time. So 5 meters per second for 5 seconds will give you a distance of 25 meters. And the correct answer is C. Question 14. Pause the video, try the question, come back for the answer. So from your data booklet, there is this equation here, 1/2 AT squared. And we can use this equation here. It starts from rest our object, so the term ut is 0 because the initial speed is 0. The displacement would be this 0.018 meters, 1/2. We want to figure out that acceleration, and the time is going to be, well, 1 millisecond for every ball. So it's 1, 2, 3, 4, 5, 6 milliseconds have elapsed. So 6 times 10 to the minus 3 for a millisecond, and that gets squared. So multiply both sides by 2, 0.036 should be equal to this A times this number squared. So 6 squared would be 36 times 10 to the minus 6. So we've got 0.036 equals A times, we can write this as 3.6 times 10 to the minus 5. So I'll write 0.036 in scientific notation, and that'll be 3.6 times 10 to the minus 2, and then to solve for A I need to divide by 3.6 times 10 to the minus 5. And I'm going to get 10 to the third, or about 1,000 meters per second squared, which is answer D. Question 15. Pause the video, try the question, come back for the answer. So we know the initial and the final speed here. And whenever we know that, that means we know the average speed. It's just going to be halfway in between the two. 10 plus 20 divided by 2 would give an average speed halfway between 10 and 20, or 15 meters per second. And we're asked for the how far, the distance, and that'll just equal V average times the time. So we know that V average is going to be 15, and then the time is going to be this 5 seconds. So we're going to get a distance there of 75 meters, which is answer C. Question 16. Pause the video, try the question, come back for the answer. So I'm going to use this equation here from the data booklet. UT is going to be 0 because we are starting from rest. S here is just going to be the distances traveled after time t. So if I want to find out S after 2 seconds, that would be a half. Acceleration is 4, and then we do a 2 squared to get 416 divided by 2 would be 8 meters. After 3 seconds, it would be a half times 4 times 3 squared, so that would be 9 times 2, or 18 meters. So between the second and thirds, S3 minus S2 would be 18 minus 8 equals 10 meters. So it traveled 10 meters between the second and third second, but it only traveled 8 meters over the first 2 seconds, which means 10 minus 8 equals 2 meters. That's how much farther it traveled, and the correct answer is B. Question 17. Pause the video, try the question, come back for the answer. What's important in this question is that the halfway point in time. So if, say, it took 10 seconds to reach 100 meters per second, the halfway point in time would be 5 seconds. And at 5 seconds, because it's got a constant acceleration, it's always gaining the same amount of speed every second. At the halfway point in time, you'd have to have a speed of 50 meters per second. Now, it's very different for distance, because in the first part of the journey, you're going slower. And in the final part of the journey, you're going faster, which means when you're going slower in that same amount of time, let's say 5 seconds, you're not going to travel as far. You're going to travel farther in the second part of the journey where you're traveling faster for the same amount of time. So it's important to make this distinction with the halfway point in time versus the halfway point in distance. So your answer has to be A, between 0 and P. Let's take a look at some vertical projectile problems. Question 18, pause the video, try the question, come back for the answer. If you've got an object that just falls from rest, a very simple equation that I like to use is d equals 5t squared. From your data booklet, that's coming from this equation, this more general equation. But of course, since it's falling from rest, that term's going to be 0. A would be the acceleration due to gravity, which we can approximate as 10. So a half of 10 gives you that 5t squared. And S here, the displacement is just going to be the distance fallen. So they talk about the third second of motion. Well, the first second of motion would be here. This would be the second of motion. This would be the third second of motion. So it'd be the interval between the second and third second that we're talking about. So we can use this equation to figure out how far does it fall in total. So this is where it's rested. So how far does it fall after 2 seconds would be given by 5 times 2 squared, which is 20 meters. And we can do the same thing after 3 seconds. How far does it fall? D3. That would be 5 times 3 squared, or 45 meters. And what we're looking for is this difference in the two distances. So this one here was 20 meters. This one here is 45 meters. And our distance here, the difference would be the difference between 25 and 20, or 25 meters. And that would be answer C. Question 19. Pause the video, try the question, come back for the answer. So keep in mind the acceleration is always downwards. for any object in free fall. But of course the velocity is upwards on the way up and it's downwards on the way down. So only on the way down are the two directions the same. So the correct answer here is D. Question 20. Pause the video, try the question, come back for the answer. Okay, so the third second is between 2 and 3. Average speed, well, it gains 10 meters per second every second. So it's going 10 meters per second after 1 second, 20 meters per second after 2, and 30 meters per second after 3 seconds. The average speed during the third second would just be halfway between 20 and 30. So it would be 25 meters per second. Question 21, pause the video, try the question, come back for the answer. If we know after 1 second the height is exactly the same as after 7 seconds, then the time to reach the maximum must be the number halfway between 1 and 7, which would be 4 seconds. So it's going to take 4 seconds to rise to the top. And we're going to have to send it with an initial speed of 40 meters per second in order for it to take 4 seconds to get to the top, because after 1 second it would be going 30 meters per second, after 2 seconds it would be going 20 meters per second, after 3 seconds 10 meters per second, and then at 4 seconds it would be going 0 meters per second right at the top of its path. So the correct answer here is C, 40 meters per second. Question 22, pause the video, try the question, come back to the answer. So keep in mind here, we're not doing a displacement time graph, we're doing a distance time graph. And the distance can only increase with time, which means we can eliminate those two possibilities. It's got to be one of those. This one here says it starts out with a fast speed. This one here, it's got a flat slope, so it's starting out slow. That one's not correct. When you throw something up, you got to give it lots of velocity, and then at the top of the path, it will be going slowly. And this would be the top of the path here. And then this is it falling down. So the correct answer is B. Question 23, pause the video, try the question, come back for the answer. So I'll come back to this equation here, d equals 5t squared, because these are balls that are dropped from rest. So the one that falls for 3 seconds is going to drop 5 times 3 squared equals 45 meters. Whereas the one that has only dropped for 2 seconds will fall 20 meters, which means the distance between them will be 25 meters, and the correct answer would be B. Let's finish off with a couple of projectile problems. Question 24, pause the video, try the question, come back for the answer. So it's important to realize in this one that if we launch a projectile horizontally, it always falls the same vertical distance as something that was just dropped straight down. So we can take the distance fallen once again to be d equals 5t squared. And being as it's falling for 5 seconds, it should fall by 125 meters. So the answer is either going to be B or D. Now let's look at the launch speed. How far it goes across will equal the initial horizontal speed. The horizontal speed stays constant the whole time. So how far it goes across will equal that launch speed, that constant horizontal speed, times the amount of time that it's in the air. And we know the amount of time in the air is 5 seconds. So if it ends up 1 kilometer or 1,000 meters away from the cliff, then that horizontal launch speed times 5 has to equal 1,000. And the horizontal launch speed, therefore, is going to have to equal 200 meters per second. So the correct answer would be B. Final question 25. Pause the video, try the question, come back for the answer. So several things to look for. Notice here that they have these horizontal lines here to show you that these two are not at the same height. And that means the maximum height of the projectile is going to be a little bit to the right of this ball in the strobe photograph. And our parabola should look something like that. Centered a little to the right. Whereas these two are symmetrical. Let's eliminate this one here because we can see that the vertical velocity isn't changing. That this length here is the same as this length here. And let's eliminate this one here because we've got no vertical velocity here, and there should be a little bit of upwards vertical velocity because it's not quite at maximum height. So it's got to be down between these two here. And what you'll notice, if you look carefully, is that this one is longer than this one here. That can't be correct. If this is symmetrical, those two vertical speeds should be the same. So we can eliminate that one. Correct answer would be A. And that's all for today, folks. Thank you very much.